Okay. Okay, good morning, class. Can you hear me? Okay, I hope you can.
Yes.
Okay, thank you. So let's start. So I am recording this class, but later I will upload in the YouTube. So later I share the YouTube link. Okay, so for today we continue with balance of two function, which is one is modulus function and another one is hyperbolic function. Okay, so and then if can I explain a bit regarding the integration by parts. Okay, so now let's start with modulus function. So for sure you all know and familiar with the modulus sign, which is also known as an absolute function. So we will put this sign. Okay, so we will put this sign, modular sign, and then at the middle the function we want to put. For example, here is x only, so this is known as a modulus function. Okay, so this function also can be continuous because there is no stop. Okay, there is no stop in the graph of the modulus function. Okay, because even the turning point also having a coordinate, and there is a we cannot define there is a no point in x and y. Okay, there will be a point in x and y even at the turning point, so we can mention this as a continuous function. So so that's the reason we can integrate and differentiate also. Okay, so this is the differentiation formula. So when we differentiate x in the modulus, so we will be getting x over absolute x. Okay, x over absolute x. Okay, so now we look at the example of the integration of the absolute function. For example, here is the absolute of x only, respect to dx. So actually, if we want to integrate only x in the absolute sign, we will be for sure getting this x times absolute x over 2. Okay, so why we will be getting this? We look into detail. Okay, so as we know, absolute function, we will be divided into two parts. One is for the positive part, another one for the negative part. Okay, so here is absolute x. So when I divide it into two parts, not dividing, it's the answer having the two values. So one will be x, another one is negative x. So that's the meaning of absolute sign or modulus sign. So the answer will be having positive value and also negative value. So positive x and negative x. So here there is a condition. For example, here is x should be greater and equals to 0. Here it have the equal sign. Here negative x is, the condition is x is lesser and equal to 0. Okay. Okay, now this is the function that we have from the absolute function. Okay, from the absolute function we have x and also negative x. So it means we try to integrate these two separate functions first. Okay, we try to integrate. So when we integrate, okay, when we integrate x and negative x, okay, we will be getting this. Okay, this is the power rule integration usage. So just this is power 1, so plus 1 will be x square divide by 2 since the power is 2. So divide by 2 plus c. And this also negative x square divide by 2 plus c. Okay. So these two value of integration we get from these two function. Okay, from these two function. Okay, now but my motive is I want to integrate absolute x. Okay, absolute x. So let's look furthermore. Okay, so since modulus function, we want to integrate the modulus function, and we know that it comes from the answer will be coming from these two integration. Okay, the answer will be coming from these two integration, and this is the value that I get. Okay, so now I know these two coming because of the condition which is greater and lesser. Okay, which is having positive x and negative x. Okay, so from here, I know that the value of the integration also the same answer, just different in the sign. Here is positive, here is negative. But the value or the answer of the integration is same, x square over 2, x square over 2. Difference is in the sign. So we will be rewrite it since we want the value for the integration of our absolute function. So we will rewrite the answer, still have 1 over 2, here also 1 over 2, so here also we put 1 over 2, and then x square will be changing into two parts. Okay, will be changing into two parts. One will be x and another one will be in the absolute sign. The x will be in the absolute sign because we know that we have two answer from the integration over here. So it means we are considering two parts for positive and negative part. So that's why we still include the absolute sign over here. So here will be x alone and another part will be absolute x. So this absolute x is representing the x positive and x negative. So this is the derivation of the not derivation, is the understanding how we get the final answer for this type of integration. If it is x alone, x alone. So it will be 1 over 2 x times absolute x. Okay, this is coming from this part, but we separate into two parts which is having x and absolute x, since our function having absolute x is having positive x and negative x. Okay, so finally don't forget put plus c. Okay, so this is the way we standardize the answer for absolute function. Okay, which is having x term alone. Okay, so this is just for the understanding how it came. Okay, it since our absolute function have condition for the positive part and negative part. Okay. Okay, if there are any questions, just let me know. Okay, now we look at the example 17. So example 17 is integrate. It is definite integral. So we integrate from negative 4 to 4. So this is the function given. So same as the previous one. So the function given is absolute x only, respect to dx. So we know that the integration for this will be this value. Okay, this formula which is or this function which is having x times absolute x over 2. Okay, so now we just put in the value negative 4 to 4. Okay, negative 4 to 4 we integrate. So we just substitute inside over here. So this will be minus with this. Okay, So finally, after substituting, we will be getting 16. Okay. You can try also check whether my answer is correct or not. Okay. So if realize over here, this is the reason why we are not considering x squared. We are considering x times absolute x. If realize over here, this is the positive part. This will be representing the negative part. Okay. So remember, when absolute x, it having the positive and negative x. Okay. Okay, later you can try and just let me know if there is any confusion or need clarification. Okay. Now we move on to example 18. Okay, for example 18, what I do is I separate into two parts. I separate for number integration and another one for the absolute function integration. Okay, for number, just simply I add x and substitute the value. Value over here is negative 1 to 1. And for here, so remember here is negative, minus. So here also minus, the function have minus. So I put minus over here, minus. So now I want to integrate this part, which is absolute function part. So I know that absolute x will be changing to x times absolute x over 2. Okay. So now I integrate respect to the value, which is from negative 1 to 1. So I substitute inside. So don't forget here have minus. So I just substitute inside the function, I get the values. So the values I substitute inside to the function and I calculate it. Finally, I will be getting 3. Okay. Okay, that's for example 18. Okay, here I have provided my own example, means extra example, which is inside the absolute function is not only x term, there is an extra like number or anything else. So how we want to integrate? So actually can use the same technique as previous, the first one I explained, but here what I do, I determine the turning point, the x value at the turning point. Turning point I mean over here, so this is the turning point. Okay, so I determine the x value at the turning point. So first we do that. So how I want to determine, just take this function x minus 5 and then equals to 0. Okay, equals to 0. So I will be getting x equals to 5. Okay, x will be equals to 5. So after that, now I separate the absolute function into two parts. One over here, another one over here. Okay, I redraw it. Sorry. Okay, give me a second, sorry. So we redraw it more nicer way. So this is the coordinate of 50. This is the range we want, 2 to 8. So this is the turning point. The turning point at the 50. So the intersection of y is at -5. Okay, -5. So means the graph maybe it will be looking like in a different way. Give me a second.